Good morning. Today I'm going to discuss about Cannizaro's reaction. Okay, so what is Cannizaro's reaction? Cannizaro's reaction is shown by aldehydes that do not have alpha hydrogen atom. Okay, so this is the main point. That is, Cannizaro's reaction is shown by aldehydes that do not have alpha hydrogen atom. Okay, so what is an alpha hydrogen atom? It is the hydrogen atom that is present on alpha carbon. Alpha carbon is nothing but the carbon that is adjacent to the functional group. In this case, it is the aldehyde functional group. Okay. Now, this Cannizaro's reaction is an example for a disproportionation reaction. What is a disproportionation reaction? Disproportionation reaction involves both oxidation as well as reduction of the reactant molecules. Okay, so in Cannizaro's reaction, one molecule of aldehyde is oxidized. The oxidation product is nothing but acid. That is the carboxylic acid. Okay, so and another molecule gets reduced to alcohol. So both oxidation as well as reduction is occurring in this. Okay, that is why this is called as a disproportionation reaction. Okay, and what is the other reactant? The major reagent for this is concentrated alkali. So this reaction occurs in the presence of concentrated alkali. So three main important points about Cannizaro's reaction is shown by aldehyde that do not have alpha hydrogen atom, carried out in the presence of concentrated alkali, and what happens to the reactant? They undergo disproportionation reaction to form a acid and a alcohol. Okay, next. So the example I have taken here is formaldehyde. So formaldehyde is an example of an aldehyde that do not have alpha hydrogen atom. There is no alpha hydrogen atom present in it. Okay. So in the presence of concentrated NaOH, concentrated alkali, what happens? Two such aldehydes react to give an oxidation product, which is the acid. In this case, you get the sodium salt of acid, namely the formic acid. Sodium salt of formic acid, which is sodium formate. Okay, plus the reduction product. What is the reduction product? Methanol. One carbon alcohol. One carbon alcohol is methanol. Okay. Next, we will proceed into the mechanism. What is the mechanism occurring? You can classify the mechanism. You can classify the steps into three steps, major steps. First is the attack of the reagent onto the aldehyde. Okay. Now you know that the carbonyl carbon has a positive charge thanks to the presence of electronegative oxygen, because of which this carbon takes up a positive charge. So என்ன நடக்குது இங்க OH minus it attacks the carbonyl carbon. Okay, and it forms this intermediate. This is an example for a tetrahedral intermediate. It's a tetrahedral intermediate. Okay, this is step one. Step one is a fast step. Step one is a fast step. Next is the step two. In step two, what happens? The tetrahedral intermediate formed collapses. என்ன ஆகுதுன்னா, it will kick out a hydride. This is called as a hydride. Hydrogen, it takes the bond pair along with it and goes and attack another carbonyl carbon. Okay, so what happens is this acts as a hydride. Okay, when hydride comes and attacks a carbonyl compound, what happens? What you expect is a reduction. Okay, so same way you see here, what happens? This aldehyde becomes a alkoxide. Okay, and in the process, this aldehyde becomes the acid. Okay, so if you look at this step, The step 2 is a slow step. Step 2 is a slow step, whereas step 1 is a fast step. And final step is a proton exchange occurs between the formic acid and the methoxide, leading to the formation of formate and methanol. Giving these are the reaction products, Cannizzaro products, is sodium formate and methanol. Okay, so what you have to remember in this is the aldehyde that is involved in step 1 becomes the acid. The aldehyde that is involved in step 1 becomes the acid, while the aldehyde that takes part in step 2 becomes the alcohol. Okay, so this is very important point. That is, I'll repeat once again, the aldehyde that is involved in step 1 becomes the acid, and aldehyde that is involved in step 2 becomes the alcohol. Okay, so this is the mechanism. Okay, another example is benzaldehyde. Benzaldehyde, again, this contains, this is the alpha carbon, and this alpha carbon contains no hydrogen. So this has no alpha hydrogen. So this molecule contains no alpha hydrogen atom. Okay. So this, in the presence of 50% NaOH, is expected to undergo Cannizzaro reaction. What is Cannizzaro reaction? One is getting oxidized and forms the salt, sodium salt. So oxidized product of benzaldehyde is benzoic acid. Another one is getting reduced. Another molecule is getting reduced. That is the alcohol. So another example I have listed here. Again, you look at it. This is the alpha hydrogen. This alpha, this is the alpha carbon. This alpha carbon contains no hydrogen. It contains only methyls. So again, this is again an example of a compound having no alpha hydrogen atom. Okay. So again here what happens? What you have to do is just oxidize to the aldehyde functional to the salt of the acid. Okay, and another one is just to reduce the aldehyde functional to the corresponding alcohol. Okay, this is yet another example involving furan to aldehyde, furan to carboxyaldehyde. So again, this contains no alpha hydrogen atom, no alpha hydrogen atom. Okay, so again, how will you write the products? Just oxidize this to acid, write the corresponding salt, carboxylate, and another one is just to reduce it to the corresponding alcohol. Okay, so this is with respect to Cannizzaro reaction. But however, in Cannizzaro reaction, there are other variants also. We'll see what are they. This is an example for intramolecular Cannizzaro reaction. Okay, it is happening within the molecule itself. You see here, this molecule contains two aldehydes. Okay, so when you are subjecting this to concentrated NaOH, what happens? It undergoes Cannizzaro reaction. Just one molecule is sufficient because this one molecule itself contains two aldehyde functional groups. Okay, so what I am doing is, one I am oxidizing it, another I am reducing it. Okay, so this is a classic example of intramolecular Cannizzaro reaction. Okay, so this is glyoxal. Glyoxal is giving glycolic salt of glycolic acid. Okay, yet another example is this phthalaldehyde. Okay, phthalaldehyde again is an example for, it's a good substrate for intramolecular Cannizzaro reaction. Okay, again when you subject it with concentrated NaOH, one of the aldehyde functional group is getting oxidized, another group is getting reduced. So it's very easy to do it. So this example is phenyl glyoxal. Okay, so here you have a combination of aldehyde and a ketone. Okay, the aldehyde group is vulnerable to oxidation. ketone cannot be oxidized easily. So in the presence of concentrated NaOH, what I am doing is the aldehyde group gets oxidized, whereas the keto group gets reduced to the corresponding alcohol. So these three are examples of intramolecular Cannizzaro reaction. Okay. Now another variant is what happens when you use two different aldehydes which do not have alpha hydrogen. Okay, that is called as crossed Cannizzaro reaction. Crossed Cannizzaro reaction. Okay, so here I am taking benzaldehyde and you are taking formaldehyde. Okay, now I'm going to treat it with concentrated NaOH. Which aldehyde is going to get oxidized? Okay, that depends upon the steric environment. Steric environment around carbonyl group. Around carbonyl. Okay, so you will see that formaldehyde is less sterically hindered compared to benzaldehyde. So what happens is when you are treating with NaOH, NaOH will first attack the formaldehyde because of less steric hindrance. So we have already seen in the mechanism. What is it? The aldehyde that is involved in step 1 becomes the acid. Correct? You recall that? So in the same way, since formaldehyde is involved in step 1, okay, because formaldehyde is first attacked by concentrated NaOH, its fate is to get oxidized. It gets oxidized. Therefore, the other aldehyde gets reduced. Okay. So every time when you take a mixture of formaldehyde with any other aldehyde, formaldehyde mostly gets oxidized, whereas the other aldehyde will get reduced. Okay. So this is another example where I am using a mixture of aldehyde with one of the aldehyde being formaldehyde. So what happens is formaldehyde is getting oxidized, whereas the other aldehyde is getting reduced. Okay, so this is pentaerythritol. Pentaerythritol, which is a good substrate for preparation of the corresponding nitro compounds, which is used in explosives. Okay. So with this, we come to end of Cannizzaro reaction. Thank you.